Okay, where can you get libraries for Python? Most publicly available libraries are hosted on Git hosting platforms such as GitHub and Bitbucket. The source of libraries is, however, far from convenient to use. In order to simplify installation and, more importantly, dependency management for different versions of libraries, Python Software Foundation, a charity organization, maintains Python Package Index, or PyP. The index is available online at https://pyp.org. And this web page distributes Python packages both in their source form and as precompiled packages that contain necessary binaries, such as pre-built dynamic libraries for Windows. Let's look for one, for example, matplotlib, a frequently used plotting library. This is how a typical page of a package looks like. In the upper left side, you have an easy-to-copy command to install a library. Let's copy that. And then you have project description, which is basically an import from GitHub homepage or README file. And then there is some extra information such as release history for different versions, downloadable files with different versions that you can install manually, and references such as reference to a homepage of the project and the source code. This index comes with own package manager utility that is named pip, PIP. This utility is typically available as part of Python installations. PIP can be executed both from terminal and directly from Jupyter Notebook cell. In both cases, the syntax is the same, and it looks like this. So pip install, package name, and then different version specificators that are optional. Alternatively, you can use this syntax, pip install -r, and then a file that will contain list of packages. Version specificators can be either requirements for a specific version, for example like this. Here we have request to install some package with exactly version 1.0.1, or a range specifying minimal acceptable package version, like this. We change equal to greater, or even minimal and maximal version range, for example like this. You cannot have more than one version of the same library installed in a single environment, and thus you need to create different environments if you get library version conflicts between your projects, or you simply don't want to update old code to new libraries. In such cases, you might want to also preserve a snapshot of installed versions of different packages that can be later used as list of packages for pip install. To do that, you just need to run pip -freeze command. And this is how the output might look like. You can see in this case it lists the name of the library and the source location of the file from which it has been installed. Because it was installed via Anaconda, it contains a reference to a local file. Instead, this file is installed via standard pip repository and uses this version. The third source of installation for a package could be also a network repository such as GitHub. After getting this output, you need to trim this list only to the packages that you actually have as direct dependencies of your project, because this list contains all packages, everything that has been installed, even the references that are not necessary to keep, because they will be automatically fetched for appropriate packages on the installation. And finally, sometimes you want to remove an accidentally installed library. To do that, you can run this command, pip -uninstall and then a package name. To run pip command from Jupyter Notebook, as you can see here, you simply need to type it in a cell. Please note that the cell should start with pip command and should not contain any other Python code for the cell to work. This is a convenient way to manage dependencies for your project. And more information on pip commands can be found using pip -h command, for example, like this. This lists standard pip help. You can also execute pip in your terminal. And if it's within the same environment as your Jupyter Notebook, then it will have effect on your Jupyter Notebook as well. Some packages might require complex binary dependencies and even have complex installation to maintain interoperability between different operating systems. In such cases, they might be absent from PyP, and as an alternative in such cases, Anaconda provides own repository of packages that can be accessed via Anaconda Navigator. To access package installations feature, you need to switch to Environments tab in Anaconda Navigator, Select the environment into which you want to install new packages. In our case, that would be Lecture 1. Then on top of the right panel, change Installed filter to Not Installed. Then using the search box in the top right corner of the right panel, filter the list of packages until you locate the package that you want to install. For example, let's install Flask. Finally, tick the box left of the package name. A suggestion to apply changes should appear at the bottom. And once you have selected all packages that you would like to add, then you just need to click Apply. After a while, Anaconda will solve all the necessary dependencies, and you will need to confirm the installation by pressing Apply in the summary window. Sometimes you will need packages that are absent in the default Anaconda channel. Such packages might be experimental, unstable, or not very popular. But if you are okay with this, you can try to look up them at the https://anaconda.org Anaconda repo. And there you will get instructions on which additional Anaconda channels you need to add to enable installation of these packages. For example, if we want to install matplotlib, you can see that it comes from CondaForge channel, and we need to add that one in Anaconda Navigator. To add a custom channel, you can click on Channels button on top of the right panel, here, and then click Add button in the top right corner of the window and type channel name. For example, we can type conda-forge. Then press Enter and click Update Channels button. After a while, Anaconda will have package list updated with new options. And now we can follow the same installation process and install our Influx client. As you can see, it is now available here. We select it, press Apply, and when Anaconda is ready, press Apply again. And then wait for Anaconda to apply the changes. You can also use conda install-c command, followed by channel name and package name, to install different packages. You can copy the example of this command from every package you will find on anaconda.org package search. And if we go to the terminal, inside our base environment, we can install this package. And when we are asked whether we want to proceed with this update, we can check what packages will actually be installed and press yes or no. Now please pay attention to the fact that right now we have installed this matplotlib inside base environment. In order to change environment, we need to use conda command again. And to switch environments, we use source, activate, and then the name of the environment. And this changes our environment in Linux or in macOS. And in case of Windows, you just omit source and type activate space environment name. This will obviously not work for Linux.